Okay, Assalamualaikum and good day everyone. In this video, we will learn Chapter 5, Kinetics of Rigid Body. Okay, this is the final chapter for this subject. Okay, next, let's overview chapter's content. So we have 3 subtopics in this chapter. First, force and acceleration. Second is work and energy. And third topic is impulse and momentum. Okay, so there are the objective, okay, for each topic. Let's review what is kinetics. Kinetics deals with the relationship between the change in motion of a body and the forces that cause this change. Okay, remember, we have learned this in chapter 3. Okay, in chapter 3, we learn kinetics of particle, and in chapter 5, we will learn kinetics of rigid body. Okay, in chapter 3, the keyword are mass, acceleration, force, velocity, and displacement, where in chapter 5, the keywords from mass, we change to mass moment of inertia, acceleration change to angular acceleration, force into moment, velocity into angular velocity, and displacement into angular displacement. Next, let's recall what is mass moment of inertia. Okay, I believe you all learn this topic. The mass moment of inertia of a body is a measure of a body resistance to angular acceleration by measuring the distribution of the mass of an object relative to a given axis. Okay, so the unit for mass moment of inertia is kg times m square. Okay, and the formula I equal to integration of mr square, where r is the perpendicular distance from the axis to the arbitrary element dm. Right? Next, review mass moment of inertia. Okay, so first, for solid sphere, Ix equal to Iy equal to Iz equal to 2/5 mr square. Okay, and next, Slender Road. Okay, Iy equal to Iz equal to 1/12 ml square. Okay, and third one is solid circular cylinder. Okay, Ix equal to half mr square, and Iy equal to Iz equal to 1/12 m in bracket L square plus TR square. Okay, next, thin disc. Okay, thin disc, Ix equal to half mr square, and Iy equal to Iz equal to 1/4 mr square. Okay, and next, thin rectangular plate. And lastly is mass moment of inertia for brick. Okay, so for information, we will use this formula mass moment of inertia in this chapter. Okay, next, parallel axis theorem. Okay, we also will use this formula. Okay, I equal to Ig plus md square. Okay, where I is the mass moment of inertia, Ig is mass moment of inertia passing through the center of gravity of the body. Okay, m mass of the body, and d is the distance between the center of gravity of the body to the respective axis or point. Okay, we will also use the formula for radius of gyration, which is r equal to mk square, or k equal to square root of I over m, where k is the radius of gyration. Okay, let's do a review. Example 1. Okay, to find mass moment of inertia. Okay, the Slender Road have a mass of 4 kg. Determine the moment of inertia of the assembly about an axis perpendicular to the pitch and passing through point A. Okay, so mass of each segment equal to m 4 times 0.2. Okay, so equal to 0.8 kg. So alert with the unit for mass from the question is 4 kg over m. So you must time with m. Okay, or distance. Next. Okay, so we know that mass moment of inertia of a slender road equal to Ig equal to 1 over 12 ml square. Okay, and next, by using parallel axis theorem, I at A equal to Ig plus md square. So Ig is 1 over 12 times m and 0.2 square plus m 0.8 and distance from the center 0.1 square. Okay, and plus 1 over 12 0.8 for m. Okay, and then L 0.2 plus m plus distance 0.2. Okay, next you will get the answer 0.04533. Okay. Next, we will learn subtopic 1, force and acceleration. Okay, so there are the content for this chapter. Okay, planar kinetic equation, translational and rotation motion. Next, equation of motion for translational motion. Next, equation of motion, rotation about a fixed axis. And lastly, equation of motion, general plane motion. Okay, for linear motion, we know that summation of F equal to MA. Okay, for rotational motion, summation of moment equal to I alpha. Okay, where M is the moment, I is the mass moment of inertia. Oh, sorry. And alpha is the angular acceleration. Okay, so next, planar kinetic equation of motion, translational and rotation motion. Okay, so first equation of motion is translational motion. If a body undergoes translational motion, the equation of motion is equal to F equal to MAG. Okay, so MAG. Okay, so M is the body mass, and AG is the acceleration of its mass center at G. Okay, so this can also be written in scalar form as Fx equal to magx and Fy equal to magy. Okay, so as you can see in the picture, okay, it's a rigid body. So magx and magy is at the center of the rigid body. Okay, so equation of motion for rotational motion. Equation of motion due to moment can be written as at point G, summation of moment at G equal to Ig alpha. Okay, so you can see here is the moment. Okay, so when rotate, you will have moment. Okay, and the moment is equal to Ig alpha. Okay, and magx and also magy. Okay, next at point P. Okay, so at point P here, or any point other than point G, okay, vector form summation of Ri times Fi plus summation of moment equal to R times Aag plus Ig alpha. Okay, and also we can see there in scalar form summation of moment at P equal to summation of mk P. Okay, next. These three independent scalar equations of motion may be used to describe the general planar motion of a rigid body. So these equations are first Fx equal to magx and second Fy equal to magy and summation of mg equal to Ig alpha or summation of mp at P equal to summation of mk at P. Okay, next. Equation of motion for translational motion. Okay, so this is important. Okay, when a rigid body undergoes only translation, all the particles of the body have the same acceleration. So AG equal to A and AA equal to 0. So the equation of motion become Fx equal to magx, Fy equal to magy, where mg equal to 0. Okay, but if point A is chosen instead of point G, okay, so point A is another point rather than G, so summation of MA equal to MAGD, where D is the distance from the point to the G. Okay. Next, when a rigid body is subjected to curvilinear translation, okay, it is best to use an anti-coordinate system, okay, which is tangent and normal component. Then apply the equation of motion as written below for anti-coordinate. Okay, so Fn equal to magn, Ft equal to magT, where mg is equal to 0, or when at point B, so summation of point moment at point B equal to magT minus h and agn. Okay, so here is the h and e. Okay, next, Procedure for analysis. Okay, so how to solve for this translational motion for rigid body. Okay, problems involving kinetics of a rigid body is only translation should be solved using the following procedure. First, establish an x, y or anti-inertial coordinate system and specify the sense and direction of acceleration of the mass center AG. So first, establish x and y or a and t, and also specify the sense and the direction of the acceleration. Draw a FBD and KD showing all external forces, moments and direction of I alpha. Next, identify the unknown. And number 4, apply the 3 equation of motion. Okay, whether rectilinear translation or curvilinear translation. Okay, remember, friction forces always act on the body opposing the motion of the body. Okay, let's see example 1. The cart and its load have a total mass of 100 kg and center of mass at G. Okay, a force of P equal to 100 Newton is applied to the handle. Neglect the mass of the wheel. Find the normal reaction at each of the 2 wheels at A and B. Okay, so as you can see from the picture, we know that the cart will move along a rectilinear path. Okay, and draw the free body diagram and kinetic diagram. Okay, so we know that this trolley is move in rectilinear path. Okay, so first draw free body diagram. Okay, and label all the forces. First, at the wheel, we have normal and B and A, and then weight 100 times 9.81. Okay, and then you have forces external 100 Newton. Okay, so any other forces? Okay, no. Okay, and next you draw kinetic diagram and label the direction of A. So A is moving to the right. Okay, and second step, equation of motion in x direction. So we know that AG is in x direction. So summation of force at x axis equal to MAG x. Okay, so direction of x 100 times 4 over 5. Okay, because the question gave in trigonometric triangle, and you will get M equal to AG, 100 AG. Okay, so from here we will get answer for AG. Okay, next equation of motion in y direction. So there are no acceleration at y direction, so Fx equal to 0. Okay, next, and A, normal force at A plus normal force at B minus weight, and also minus 100 times 3 over 5 equal to 0. Okay, Next, you get equation NA plus NB equal to 1, 0 for 1. Okay. So, next step, in chapter 5, we have extra formula for moment. So, next, we find the sum moment about G. Okay, sum moment about G. So, as you know, okay, there are no moment since this card is moved in translational motion. So, we know that mg is equal to 0. Okay, and next find all the moment and u equal to 0. Okay, so first NA, okay, NA times D for A from G is 0.6. Okay, minus, okay, because you assume, look at here, okay, we assume counterclockwise, positive. Okay, so NA will moving counterclockwise and NB will move clockwise. So NB will become negative. So that's why NB is minus NB. So NB times 0.4. Okay, distance from B to G is 0.4. Okay, next plus, okay, plus 100, okay, because 100 Newton will move counterclockwise. Okay, times 3/5 times 0.7. Why 0.7? Because 0.3 plus 0.4. And next, minus 100 4/5 times 1/2, sorry, 1.2 minus 0.5. Okay, because we want this D, okay, from the force to the center at G. Okay, so you get this equation, this new equation, and then solve simultaneously from previous equation. You get NA and NB. Okay, please understand by doing this example by yourself. Okay, so next video we will learn equation of motion for rotational motion about a fixed axis. Okay, thank you for watching. Good luck and Assalamualaikum.